Alright, so in this video we are going to discuss the rule of order of operations. Sometimes they just call it the order of operations, but I think the rule of order of operations kind of makes it more significant in that it's a rule. It's not optional. You don't get to decide which order you want to do it in. You must do them according to this rule in this order. And so what it is based on is these letters, PEMDAS. People will say, please excuse my dear Aunt Sally. And it just sort of helps you to remember it. It's kind of cutesy. It's a little mnemonic. And some people just call it PEMDAS, PEMDAS. But this stands for parentheses, exponents, multiplication, division, addition, and subtraction. It's sort of like the order of importance. Now, in parentheses is also above and below a fraction bar, which we'll talk about later. But this multiplication and division, they are equally important. So what you do is you do anything that's inside parentheses, then you do any exponents, then you go, do I have multiplication and division? Those are asked together. And if you have, several multiplications and divisions in there, you don't do the multiplication first and then the division. You do multiplication and division in one sweep through whatever order they show up in. So if your division showed up first, you would do that first. If your multiplication showed up first, you would do that first. This is where all of those ones that show up like on Facebook and the internet and quizzes and things like that are all based on, are you going to do this according to the rule of order of operations, or are you going to make up your own rule, which doesn't work. Then addition and subtraction are also done together in one pass. You would do them in the order they show up. So if you have a subtraction that shows up before an addition, you would do it first. Or if you have an addition first, you would do it first. All right? So those come in pairs. Now, before we get busy, I want to, some of you may not know what exponents actually do, so we're going to have just a brief couple of minutes on exponents, and then we're going to get busy. So exponents are shorthand for repeated multiplication of the same number. So if I have 3 times another 3 times 3, I have 4 3s. And the shorthand for that is I have a 3. They call that the base. The base is the number that's being repeated. And this little number up here in the corner says how many times it was actually there, but we're shortening it to a small shorthand kind of notation. So this is a base of 3, and the little number up here in the corner is called a power or an exponent. And it says how many times 3 is there. It does not mean 3 times 4, which is 12. It means there were 4 3s originally. So this was considered kind of expanded form because they take up more room. The N doesn't look right. And this is exponential form because it has an exponent in it. So you would go, if you look at this right here, you would say, well, 3 times 3 is 9, times another 3 is 27, times the last 3 is 81. So 3 to the 4th is 81. If you have 5 times 5, that's repeated multiplication, so you have a base of 5, because that's the number that's being repeated. It's there twice, so the power is 2. So you could say 5 to the second power, but because some powers show up more often than others, and one of them is a 2, they call it squared, 5 squared, kind of like square feet in the area on your, if you're going to measure your room for buying carpet, and you would say there was length times width is so many square feet. All right, So this could be 5 to the second or 5 squared. If you had something, and that would be 5 times 5 is 25. So 5 to the second power, 5 squared is 25. If you had 6 times 6 times 6, your base is 6. It's there 3 times, so your power is 3. This is another one of those that's got kind of a cutesy name. So they would say this was 6 to the third power, or 6 cubed, like cubic inches in your refrigerator. Okay, so 6 times 6 is 36 times 6 is, I think, 216. Okay, 36 times 6, 3, 18, 3, yeah, 216. I was right. Okay, if you ever forget one, you just do it out longhand. Now, if you had something like 8 times 2 to the 6th, this power of 6 applies only to the 2 because it's the number that is just right in front of it. So you would have 8 times whatever 2 to the 6th is, or you can think of it as 2 times 2 times 2 times 2 times 2 times 2. Or, you could multiply it. Some people count on their fingers while they multiply, and they'll go, okay, I've got 6. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So this would be 8 times 64. And this one I did work out. It's 512. So the important thing here is that the power only applies to the number that's immediately in front of it. Now, one of the things that's really interesting is if you have something like 7 to the first power that says you have a base of 7, you only write it down one time. So anything to the first power is itself. All right? Likewise, 1 to any power, 1 times 1 times 1 is 1. 1 to the 8th power, 1 times 1 times 1 times 1 times 1 times 1 is 1. Okay, so 1 to any power is 1. Anything to the first power is itself. All right, now here we go. So remember we had, please excuse my dear Aunt Sally. So we had parentheses, exponents, multiplication, division, addition, subtraction. These two go together and these two go together. All right, so if I have, let's start off really basic, 20 plus 4 times 2. This is how you learn this rule of order of operations by repeating it over and over and over. So one of the easiest ways to do it is just to start at the top and ask yourself the questions all the way through, even though you can probably maybe tell what to do with this. Okay, so you go, do you have parentheses? No. Do I have exponents? No. Do I have multiplication or division? Yes, I do. And I actually just have a multiplication. So I'm going to come down here, and 4 times 2 is 8. Do I now have any addition or subtraction? Yes. So I have addition, so I would add them together. And this is what you get when they ask you to simplify this expression, because it's not an equation. All right, what if I had 64 divided by 8 times 4 plus 2? And this is beginning to look kind of like the ones that you see online, where they're going, what do you get? What do you think the right answer is? And you get all these different answers. So if you get used to this order of operations, you'll be the one with the right answer. So we would look at it and go, does it have parentheses? No, it does not. Does it have exponents? No, it doesn't. Does it have multiplication or division? Remember, you ask those together. Yes, it does. Now, so we're going to go left to right in the order that they show up, not multiplication first and then division. All right. So I'm looking for multiplications and divisions left to right as they show up. So my first one left to right is a division. That's okay. I'm going to do that first. So 64 divided by 8 is 8. Everything else stays the same. I'm still on this multiplication or division level, so I have another multiplication left. So 8 times 4, 32. I've done all my multiplications and divisions. So do I have any addition or subtraction? Yes, I do. I have an addition. So this is the simplification of that one. What if you have 10 plus 5 cubed divided by 5 times 10? Please excuse my dear Aunt Sally. Do I have any parentheses? No, I do not. Do I have exponents? Yes, I do. So I need to stop and figure out what that is. So I'm going to just pull this out and say 5 to the third power, or 5 cubed, is 5 times 5 times 5, and that is 125. So I'd have 10 plus 125 divided by 5 times 10. All right, didn't have any parentheses. I'm through with my exponents. Do I have any multiplication or division? Yes, I actually have one of each. Division is showing up first, so I hold on to my 10. This is the first one that shows up left to right. 125 divided by 5 is 25 times 10, and here's my multiplication. So it's 10 plus 250, and I have my additions or subtractions left, so I just had an addition. And that would be this answer. Now watch what happens if it had had 10 plus 5 cubed, but we had parentheses. Everything else is the same. All right, you would say, do I have any parentheses? Yes, I do. So I'm going to look inside the parentheses. Can I add 10 to 5 cubed? No, I cannot, because addition is way down here at the bottom of the list. So you can't skip to the bottom of the list until you go and work your way through the whole list inside these parentheses right here. So just ignore the rest and say, inside the parentheses, do I have exponents? I surely do. So I'm going to have the 10 that I'm going to hang on to, plus, remember that we have already decided that 5 cubed is 5 times 5 times 5, which we decided was 125. All right, divided by 5 times 10. We are still inside the parentheses. Okay, you can't move on over into here until you're through with the parentheses. So do I have any multiplication or division inside the parentheses? No, I do not. Do I have any addition or subtraction inside the parentheses? Yes, I do. And so I would have 10 plus 125 is 135. Now, I'm done inside the parentheses. There's nothing else to do. There's no powers, additions, subtractions, multiplications, or anything. So these parentheses have performed their function, which is to get me to kind of isolate this little part right here and do all of those functions first. So now I'm going to say 135 divided by 5, because I have a choice between multiplication and division. This is the first one. 135 divided by 5 is 120. I'm sorry, is 27, not 127. And then I have the times 10 left. And so 27 times 10 is 270. I have no additions or subtractions, so I'm done. And you can see how you don't get the same number if you take a different path. Sometimes that happens. All right. Now, as in, sometimes you get the same number, but I'll show you an example of that. All right. So when teachers design these quizzes, we have to decide if you truly understand all the ins and outs, because every time you do math, as you go forward in your math career, coursework, or whatever, everything you do, you have to simplify. You have to add like terms. You have to multiply, divide, raise the powers. And if you do them in the wrong order, you'll be getting the wrong answer, even if you understand the more complicated technique, because this basic rule of what do you do when was not kind of ingrained into your your mind, right? So they have to make sure you understand all the nuances. Now, if you have something that looks like this one right here, can you see how it's just so tempting, since we read, left to right, to go, oh, 5 plus 2 is 7. It's just right there. I mean, really, can't we just do that and get it over with? No, because addition and subtraction is way down there at the bottom of the list, and we haven't gone through the rest of the list yet. Now, interestingly for me, okay, I have discovered when I made up tests like this for students that they were definitely tempted by the 5 plus 2, but for some reason I never really understood the wherewithal or anything. 5 plus 2 is extremely tempting. 5 minus 2 is just like overwhelmingly tempting. Okay, so they might fall for the 5 plus 2 is 7, which is not true. But they definitely tended to fall for 5 minus 2. Even though we had worked on these in class, I don't know why the temptation was so ferocious during an actual quiz, but it was. All right. So you are not going to fall for that, because you are always going to start at the top right here and go, does it have parentheses? Yes, it surely does. So we are going to ignore that tempting 5 plus 2 and go 5 plus 2, and inside parentheses, do we have exponents? No. Multiplication or division? No. Addition or subtraction? Yes. Okay, 6 minus 4 is 2. We have this exponent on the outside, plus 3 divided by 3. Okay, now we're still inside. We can't let go until we're absolutely sure we've done everything the parentheses want. So the parentheses wanted us to figure out what 6 minus 2 was, which we did. And then it wanted you to take that quantity and to square it or raise it to the second power. So this right here, this part, that was terrible looking, wasn't it? Is actually 2 times 2. That's this, not the outside 2. So I have 5 plus 2. There's an implied times right there. Times. And 2 times 2 is 4. So this 4 came from here. All right. Plus 3 divided by 3. So you go, okay, I've done my parentheses. I've done my exponents. Do I have any multiplication or division? Oh, yes, I do, actually. I have a multiplication here and a division there. Which one do I do first? Left to right. So I'd go 5 plus 2 times 4 is 8 plus 3 divided by 3. Let's do this one step at a time. So 5 plus 8 plus, and 3 divided by 3 is 1. So 5 plus 8 is 13 plus 1 is 14. You okay? Now, if you have fractions, let's say 9 minus 2 times 4 plus 3 squared over 5 times 3 minus 1. Now, the fraction bar sort of fits in with the parentheses, so the fraction bar separates this into a numerator section and a denominator section, the top and the bottom. So you have to work the top down until it's all simplified, and the bottom down until it's all simplified, and then you work the two together to reduce them. All right? So we're going to work in the numerator. So here we go. Please excuse my dear Aunt Sally, or PEMDAS. Do I have any parentheses? Yes, technically above the fraction bar is a set, right? Inside the parentheses, do I have exponents? Yes, I do. So this 3 squared right here is 3 times 3. So I have 9 minus 2 times 4 plus 9, which is 3 times 3. And you cannot say 9 minus 2 is 7, right? Because addition and subtraction is way down here. And I'm not going to clean up the denominator yet, though it's okay to clean up the numerator and then clean up the denominator at the same time. You can clean them up, kind of toggling back and forth, going, work on the top, work on the bottom, work on the top, work on the bottom, work on the top, work on the bottom. But for keeping everybody on track, because I can't see you, so I don't know how comfortable you are with this, then we're going to just work on the top for right now. So you would say, okay, I've done my exponents. Do I have any multiplication and division? I have a multiplication. So 9 minus 2 times 4 is 8 plus 9. Right. And then we would work our addition, subtraction left to right. So 9 minus 8 is 1 plus 9. 1 plus 9 is 10. And now I'm through with the numerator, and we're going to move down to the denominator. And you would say, oh, I have parentheses. Inside the parentheses, 3 minus 1 is the only thing to do, so I'm going to do that. Then I've accomplished the goal of the parentheses, except it also wants you to multiply. So you'd have 10 over 10, which is 1. You could have done it like this and could have gone, okay, you could have said, okay, I'm going to work on the numerator, and you would have gone, all right, I have my multiplication, which is 8 plus 9, and then you could have said, okay, now I'm also going to look at the denominator and ask the questions on that one at the same time. So I have parentheses, yes. Inside the parentheses, I don't have any exponents, multiplication, or division, but I do have a subtraction. So I did the top, then I moved down to the bottom, then I'm going to go back up to the top, okay, like this, and then down to the bottom. So I'm just going to go up and down and up and down and up and down. So then you would go, all right, so 9 minus 1 is 1 plus 9, and over here you have 5 times 2 is 10, and you'd have 10 over 10 and 1. And you get done, what, two or three steps, depending on how you want to count it earlier, but you still get the same answer. Now, sometimes when you do these problems, you'll have something like 15 divided by 3 times 3. And so if you go left to right the way you're supposed to, you would say 15 divided by 3 is 5 times 3 is 15. Okay? Now, are you doing okay there? Sometimes people say, okay, what if I wanted to go down here and find this part first? That would be 9, right? So you would have 15 divided by 9, which is some strange fraction, and you'd get 15/9. See how you get different answers going different ways? So if you have multiplication and division, you have to do them left to right. You can't just jump down here because you like multiplication better. But if you had something like, I think we may stop right there. I think that'll kind of get the idea across. So this is just a kind of refresher, maybe for some of you. You don't have any memory that you saw this back in your previous schoolwork. I'm not sure where they teach this to you, if it's in elementary school or middle school or high school, but at some point they may have covered it, but that doesn't mean that it stuck with you or that you're not using it subconsciously. So I hope this helps you to be a little bit more conscientious, a little bit more aware of being careful what order you do these in. Okay, so that will be it for right now.